application schematic review. So we have received our customer schematic, and in this session we will review the both schematic and check the point by point. So what is the AVAS system? The full form of the AVAS system is AVAS Acoustic Vehicle Alerting System. So we are using 32-bit microcontrollers and one amplifier. So we are using i94100 series 32-bit microcontrollers, support up to 200 megahertz, and this is ARM based Cortex M4. This microcontroller support the peripherals device, multifunction timers, watchdog timers, RTC, PDMA, UART, SPI, I2C, PWM, GPIO, USB 1.1 device, not USB smart storage, only USB device, I2S, DMIC and audio DPWM modulator. And the applications, you can see here the application support: audio processing platform, consumer products, industrial automation, home automation, security alarm system, and system supervisors. So you can see here our reference schematic. So this is the customer schematic, this is our microcontroller, and this is the amplifier. And you can see here this is our AVAS reference schematic, and this is over the amplifier. So now check one by one. So I have already mentioned this is the customer schematic. Okay, so they are using the MCU i9412A 124AYU. So this is 48-pin microcontrollers, and you can see here pin number 1 start from here to ending 48 pin to here. So you can see the pin number 1 PB0 is connected to the I2C serial clock, and PB1 connected to the I2C SDA. Now one by one we need to compare with this our reference schematic. This is Nuvoton. Pin number 3 123 PB2, you can see here connected with the 0 ohm resistance to amplifier IRQ pin, and pin number 4 connected with amplifier DIG pin. So you can see here the 0 ohm resistance here, and you can see here 0 ohm resistance here. Now move to the next point. You can see here pin number 4 is open, and here is pin number 4 is open. Sorry, pin number 5. Pin number 5 and port number 4, PB4. And you can see here the reset pin is connected with the resistance to the ground with the given 3.3 power supply. So 3.3 power supply with connected to the 0 ohm. This is okay. So customer, I think customer have made this schematic same as our reference schematic. Now move to the next point. This pin number 7, 8 is open. So you can see here the pin number 7 and 8 is open. You can see here the LDO cap pin, In the LDO cap pin, ground with the capacitance, so they are using 1 microfarad 16 volt, and here is also same the microfarad. So VSS is connected to the ground, VSS and AVS both pin. So here is also VSS and AVS pin is connected to the ground, and you can see here a VDD pin. VDD pin is connected to 3.3 voltage and ground with the respect to the capacitance 1 microfarad 16 volt. Now move to the pin number 13. In the pin number 13 pin, again a VDD pin, a VDD analog VDD pin. So you can see here in the both circuit C3. So mention is 0.1 ground with the 0.1 microfarad 50 volt and 1 microfarad 16 volt. So these both pin both capacitance value are okay. Pin number 13, 14, 15, 16, 17, 18. 13, 14, 15, 17 and 18 pin open, and pin number USB VDD3 is connected to the ground. And the decoupling capacitor 0.1 microfarad and 1 microfarad. And the pin number 20, 21, 22. Pin number 20, 21, 22 is open, and PD03 is connected with the, you can see here, I2S0. B clock and and RC clock and ISD0 pin. Pin number 26 and 27. You can see here the debugger. So you can use Nuvoton debugger Newlink Pro for debug the microcontrollers. The pin is a data clock, reset, ground, and one more pin VDD. So in our reference schematic is same. Now move to the next pin number 13. Also this pin also is open and connected with the INTC and I2C1 SD and SCL. So this is, you can see here, I2C0 and this one is I2C1 channel. So we are given 3.3 voltage, and you can see here PA4, PA5, PA6, PA7 and PA8. This is your UART 0 TX pin and SPI 0 clock MOSI, sorry MISU and MOSI. So same in our reference schematic pin number 37, 38, 39, 30, 40. So this is your SPI 0 module, and and 40 and 41 is UART 0. Same customer using this UART in their application. And this pin, these all pin are open and these all pin are open. This is for debugger, customer are using same and in the reference schematic. So this is all about the microcontrollers, and now this microcontrollers interface with our audio amplifier. So some pins is connected with the amplifier. So I will show you in this schematic. This is customer schematic connected to the amplifier, and this is our amplifier IC, as you can see. Now we can check here, amplifier is set, connected to the amplifier is at pin 2, I2S0 D0 connected to the amplifier I2C. DHN 2 pin and LRC clock connected to the I2CS and I2C0B, I2C BLC clock, SCL and SDS. So these the pins is connected to the amplifier. And one more thing, uh, apart from these two ICs, we are using one more IC. The name is microcontrollers M0823 for the CAN interface. This is low pin count MCU from Nuvoton. I will share you the part number. So some pin connected to the M0823 microcontroller like I2C1. This is the channel 1, and you can see here channel 0. Channel 0 is connected to the amplifier, but channel 1 is connected to the microcontrollers. And SPI 0 is connected to the microcontrollers SPI module. Reset and UART 0, which we have discussed here. SPI here and UART is here. UART also connected to the microcontrollers, not amplifier IC. So see here over an AU83U110WZ. This is our amplifier IC. So this is customer schematic and this is our reference schematic. So I have already, and we are checking some pin number 1. You can see here pin number 1 start from here, and this is the 32 pin IC. So 32 pin IC pin number 1 is connected to the 12 volt. Here we can give 12 volt, and you can see here the 12 volt also here is connected. So in the if you have any issue and any problem regarding the schematic verification, so you can use one by one point, take our reference schematic and make the your application schematic. And if you want to change any channels and any pins, then you can discuss with us so that we will guide you. And pin number 2, now back to the point. Pin number 2 VDD speaker pin. So given 12 volt here are also connected to the ground with the 0.1 microfarad. This is the our address pin. You can see here address 0. So in our reference schematic we have mentioned the address 010101. You can see here sandwich address, and address 1 and address 0 is connected the same with the ground with the 100k resistance. So you can see here BCLK pin, which we have discussed in this microcontroller schematic. Here this is the BLC pin, and ground, this is a snapper circuit. So customer using same schematic as you can see. So I think this schematic looks fine. So we need to give the customer go ahead to make the PCB, but as of now I don't have a microcontroller schematic, so this pin is connected to the microcontrollers. But customer is already working on this M023 microcontrollers in some projects, so they don't have a problem, so that they have sent only AVAS application circuit. That's why. So this is a small review on our microcontrollers and our AVAS application circuit. So if customer has made the PCB, then I will show you the PCB and give the small demo on AVAS application. Now I am going to reply to the customer about this reference schematic, because this reference schematic is okay. I have compared. So दोस्तों please help to like and subscribe my channel Tech with Embedded. So in the next video and session, I will give you some demo about some applications. So although mm, so now I'm going to close the live session. Thank you for your support.